Hello and good morning. Welcome to the session on RDF Roadmap, creating a mapping for linked data adoption and the DC specification for simple tabular application profiles. Just a reminder, this is being live streamed to the LD4 YouTube channel and recorded and will be saved on YouTube for future viewing. So this slide here that I thought we have some resources just to draw your attention to the conference website, which you've likely seen at this point. We do have a code of conduct link, our Twitter handle, hashtag, feel free to engage in social there. And then also within Slack. And also we have a tech support channel within Slack if you need it. And let's see, with no further ado, I'll now introduce our first speakers, Meredith Hale and Mark Baggett. Meredith Hale is the metadata librarian at the University of Tennessee, Knoxville. She manages the creation and sharing of metadata for digitized special collections materials and provides technical support to the Digital Library of Tennessee, the state's DPLA service hub. Mark Baggett is the head of digital initiatives at the University of Tennessee, Knoxville. So I will stop sharing and you two, please feel free to take it away.
Thanks, Jim. I'm going to go ahead and share my screen. Okay, so today Mark and I are going to share our process behind creating a mods to RDF mapping document. Rather than going through the mapping decisions we chose individually, this session aims to highlight the thinking behind our decisions, as well as why we decided to create this document to begin with, and also what we might change about it now. So while the mapping itself isn't going to be covered in detail, we invite all of you to explore the bit.ly link on this slide. I'll begin today just with a brief history of how we got here, and then we'll transition to discussing our philosophy for selecting properties, the structure and features of the document, and our reflections on the process. So throughout, we will be looking also for attendees to share their thoughts and experiences about moving from XML to RDF to broaden the discussion, so please participate as you can. So the University of Tennessee libraries have demonstrated sustained commitment to linked data. Our journey began with moving from Dublin Core to mods for the description of our digitized special collections materials in 2014, as well as a migration to Islandora 7. So following this transition, URIs became a much more prominent aspect of our records in order to support a move to RDF-based platform. Christina Harlow developed 2 reconciliation programs for OpenRefine that made enriching our data with URIs less labor-intensive. When I arrived in 2017, I continued this investment in linked data through remediating all of our collections, which had not yet moved to mods or Islandora. So with over 80 collections, this took a little bit of time, but I and the libraries believed it was worth our effort. In the summer of 2020, Digital Initiatives began investigation into 2 next-generation platforms, Islandora 8 and Hyrax. Given that our Islandora instance is built on Fedora 3.8 and Drupal 7, and both are reaching end of life, the move to a new platform is necessary. While a product of necessity, we also felt that this move was a good opportunity to more fully embrace linked data. So given staffing, we decided that working with a vendor on this transition would help us be more successful. As of this summer, the RFP process to select a vendor has been completed. And our mapping work, which we're going to talk mostly about, was conducted in the fall of 2020. So as noted, considerable effort was invested in reconciling string values with controlled vocabularies between 2014 and 2020. This was achieved using OpenRefine and associated reconciliation services. As you may know, services like Wikidata come with OpenRefine out of the box. Other services like the Getty Vocabularies, Library of Congress, and geonames can be added. At UTK, we've made Christina Harlow's reconciliation code for LOC and geonames easier to use for students and catalogers through hosting it as a Heroku web application. This essentially cuts out the need for any use of the command line. Instructions with the reconciliation links are shared on these slides if you want to look a little bit closer at the Heroku. So when starting this position, I thought that adding URIs through reconciliation would unlock our linked data future, and that was it. While this work is critical, it's most definitely not the only work to be done. So throughout our linked data journey, we've often realized that things aren't quite as straightforward and shiny as they might initially seem. And throughout today, we're going to talk a little bit about a few of our realizations. So until 2020, remediation work resembled this chaotic slide. For all terms in our metadata, I sought to find the controlled string that concept to be represented by, whether it was a resource about birds or pelicans or pumpkins, whatever. But as we began considering our next generation system, it became clear that we needed to focus not only on having URIs for strings within metadata records, but also seriously considering what properties we wanted to use to associate our descriptive elements to the resource itself. So in this postcard that depicts 3 bears, we do want to have a URI to represent the concept of a depicted bear. But we also want to relate the bear URI to the resource itself through a property. We need to know what the predicate of the triple is. Ultimately, we could say that the predicate relating the object bear to the postcard is DC subject. So this work of determining the best property used for existing metadata was the bulk of the work we actually did in creating our mapping. So whether or not we had a string or a URI for the object value, this had an influence also on what properties we decided to pick given their expected domain. So as you may know, there are a number of mappings that we could have used rather than create our own unique mapping. One is the mods to bitframe mapping. There are a number of reasons we didn't decide to use it in the end. It is currently listed as a work in progress, and it doesn't seem that many institutions have adopted it. It also uses a lot of blank nodes and minted objects, which our group was philosophically against. Being part of the Islandora community, we also naturally were aware of the mapping, the metadata interest group I'd created for the move to linked data in Islandora 8. Samvera had also developed a mapping before our work began. So while our work was heavily informed by these 2 documents, and there were many instances where we borrowed pretty heavily from them, starting the process, we didn't feel confident that we would know for certain how much data we might lose in the transition. And we felt that we needed to look more closely at our metadata to understand its idiosyncrasies. So to get us started off, we have a question to engage everybody in the audience. We're in this process of migrating to an RDF-based system. We wondered if others are, or if they plan to, or if they don't plan to. So if you could just go to slido.com or use the QR code, we can see kind of what the audience is like today. So far we have 100%. Let's see. Yeah, so it's interesting to see what people are putting in. Definitely quite a bit with no, we do not plan to. Still quite a bit with yes and no, but we kind of plan to in the future. So I'll give it a few more seconds to try to stabilize a little. We'll see where we're at. Yeah, it's interesting to see the no, we do not plan to at an LD4 conference quite a bit. And I'd be interested later in hearing kind of your reasoning for that, or if it is perhaps in the future too. So I think I'm gonna call it at that, but I really appreciate your participation. And I'm gonna hand it over to Mark, I think.
Thanks, Meredith. So Meredith covered some things, but I want to talk about really how we got to the point of of really deciding to do a mapping and a working group to develop that and the reasons for that. So Meredith talked a little bit earlier about, our journey towards linked data and how it started a long time ago. But really the impetus was really the project that we did last summer. Last summer, we investigated a move to Hyrax or Islandora 8 as a replacement for our Islandora 7 stack. And really that was done for a couple of different reasons. One, it was just to get us thinking about what we wanted in a next generation system. And also was to try to get us to think about like gaps in our knowledge and really what we need to do to be prepared for migration. But what we discovered, which was interesting, is that even though we've been doing all this work since 2014 to prepare for linked data platform and all the stuff, that our developers really didn't understand what we've been doing or what we were trying to do. And that became present and obvious when we did start migrations, and we saw how lossy some of our metadata was. And I also think it's fair to say too that it was it also kind of showed as we had discussions and stuff even before this happened, that even us as librarians had some naiveness about what we've been doing and how easy that would be able to implement. So really this came about with a working group that had charge to really get together and develop a shared understanding about what would be difficult for moving our mods to RDF and what we would need to be thinking about and why that was complex. Also, another part of the charge was really just simply to get a holistic view of our mods and think about how that related, its text nodes, how it related to RDF properties in general. I think genuinely we have a pretty consistent use of our elements across our entire repository, but each collection has some more complex things than other ones do. So we really wanted to start by just looking at what our mods look like and what was there and what we need to think about in order to decide what we wanted to drop, what we needed to take over, and then how it should be represented in RDF. And then finally, we wanted to use all the resources in the greater digital library community to develop a metadata application profile that details how we should transform our mods to RDF. You can go to the next slide. So because, again, we were developers and librarians, and we were trying to get on the same page, develop some sort of shared knowledge here. It's only natural that the working group that came out of this should be have representation from both. So what the final group was our lead developer, Matt Jordan, and a developer, Bridger Dyson-Smith, who had historically worked a lot on our metadata indexing and metadata display, and then Meredith, who had done a whole lot of work to help us prepare for our linked data future and getting URIs into our mods, and then me, who kind of worked on both sides of the coin. Really, this was the group that came together to try to answer those three deliverables. You can go to the next slide. While all of us had, to some extent, some experience with metadata and had some expertise there, none of us felt we were experts when it came to RDF or linked data, and really that necessitated us developing some shared understanding about what RDF and linked data was, and really to have discussions so that we spoke with a common vocabulary and there was no confusion around semantics. So to do this, we really started out by trying to do readings and then have conversations from this. And really oddly, we started with this book. And you might be like, why this? And there's a couple reasons for that. One, the honest truth is because several of us owned it and it was just easily accessible. But the bigger thing is, I think we the thing that we learned from our project was that the developers really didn't understand what we were trying to do, and we didn't understand what some of the things we'd been trying to do, why that would be hard to implement. So we wanted to pick a resource that was targeted at developers. So we started with this book. And then honestly, chapters in this book is what led us to read the weird things that we did. We read everything from TBLs 4 principles of linked data, to more technical things like best practices for publishing RDF vocabularies, how to publish linked data on the web, cool URIs for the semantic web. We read all these things that were very technical, and you'll see what happens because of that. And then obviously we read mods to RDF mappings from various groups such as Samvera and Islandora. Go to the next slide. So I want to talk, before we get into the actual mapping itself, like what the outcome of like the discussions and readings was. And really what happened that was interesting is that we kind of, before we even got started to develop a philosophy or set of principles around like what our expectations were for selecting our RDF property, and also for what like the object of our triples should be. And so I want to talk a little bit about those and what that looked like. You can go to the next slide. So first was just simply, we wanted to use popular and bibliographic ontologies. First, start with and use core vocabularies. And by core vocabularies, we just mean like the vocabularies that are used across any RDF application. Things like RDF, RDFS, DC terms, DC, SCOS, etc. And when we couldn't use a vocabulary like that, we wanted to use something that was popular, of a popular bibliographic ontology, or really more things that were a vocabulary that was popular in libraries, archives, and museums, things like BibFrame. We also didn't want to duplicate effort, so we set out not to like try to identify vocabularies on our own unless we had to, and like looked at other mappings as a starting place for what we were trying to do. And then ultimately, for when we were trying to use a vocabulary or a property specifically, we tried to make sure that that adhered to the rest of our philosophy. You can go to the next slide. This is one like that definitely came out of our readings, and it's one that you'll see throughout. But we got really caught up on choosing dereferenceable and content negotiable URIs, and I want to just talk about what we mean by that and how we interpret that for ourselves. So dereferenceability is really, you know, that comes out of the 4 principles of linked data, like number 2 and number 3 specifically, which is use HTTP URIs to allow things to be looked up and interpreted, and then use the standards to do that, things like RDF and Sparkle. And so essentially what we wanted to do there was just make sure that if we had a URI and we were using it, that you could look that up and somehow get RDF. But we took that a step further, and that really, I think, was inspired by our reading. And we said, okay, not only does it need to be dereferenceable, it needs to be content negotiable. And what we mean by that is that if you have a URI and you query it for a web server, we ask explicitly for the web server to give us back some form of RDF, that it complies, and that's what we get back. We don't get back text HTML that we then have to use to try to figure out how to get the RDF. So this is a principle that we selected really for a good reason. I think we wanted to have whatever we were going to do to be easily implementable, and to really make it easy to consume whatever we're doing. And so this was something that that had really noble beginnings, but we'll talk more about later, like where that became complicated. Next slide. Also, we wanted to adhere to any rules or things that were indicated by the RDF property itself. So specifically, we wanted to acknowledge that if we were using a property, that we recognize that that property had might indicate how it should be used, and if so, we wanted to try to follow that. So essentially, if a property had a domain or a range property, we wanted to make sure that we were thinking about how that us using that property would relate to our subjects and objects of our triples. Specifically, we wanted to think about, hey, can we follow it? And if we can't, we need to justify why we can't, but we're still using it. Next slide. Also, this is another thing that came out from our reading of really, I think, the Samvera mapping specifically, which was just to avoid blank nodes. When I say avoid blank nodes, I mean avoid blank nodes as like the object of our triple. We certainly use URIs that have URIs that represents properties and our objects that use blank nodes, but we don't want to add blank nodes ourselves. I think the Samvera doc says something like, you know, hey, that blank nodes are hard to implement in certain systems. We read more, and we found this this quote that really like that I think really it was the reason why we followed this, which was by Sandra Hawk, that blank nodes are a convenience for the content provider and a burden for the content consumer. And so how we interpret that is like, it might be easy for us to create a blank node to represent the object, but what that does is it makes it hard for the developer or whatever the consuming application is to really do something with that. And we wanted to avoid that. Next slide. So this, of course, leads us to having to mint new objects, but we also made this principle that we would only do so as a last resort. And we define that as this, which is essentially we will mint a new object if we're creating a local authority to represent a subject, person, or concept, or linking a local concept to an existing object represented by a URI. What we were trying to avoid here was minting new objects for every single complex XML node in our existing mods or URIs that already existed. And I'll turn it over to you, Meredith.
So our final philosophy point actually just dealt with strings, things like titles and stuff. We wanted to have some rules on how we're going to deal with those. So, generally we followed, other descriptive practices. So formal standards include, resource description and access and the descriptive cataloging of rare materials manuals. Also really important for us at the University of Tennessee, we act as a DPLA service hub. So DPLA's metadata application profile also informed a number of our decisions for strings. As a caveat to this, ultimately some rules that made the metadata more accessible were also privileged. So one example is our decision to not retain information about whether or not a title was transcribed. And this obviously goes against the descriptive practices mentioned here on the slide, but we felt that it simplifies the metadata for the user so that the title is either the main display title or an alternative one, so it's easier for them. And also additionally, this decreases the complexity of our mapping, making it easier to actually migrate in the end. So as you can see, developing just a shared understanding of our work before delving into the work of creating the mapping takes a lot of effort. Now we're just going to share some of the decisions we made in structuring our mapping document that we felt helped make it more useful for us and for others. And if you, again, the link here just goes to our mapping document if you want to look a little more closely. So in creating our mapping document, it was important for us to consider who it was really for and what those individuals or groups would need to achieve using the document. So obviously the document was useful internally in helping UTK libraries identify and address metadata inconsistencies and grapple with what was important about our existing metadata that needed to be maintained in the future. It also serves as a resource for the Digital Initiatives Department and the libraries generally to better understand this work and appreciate the effort it requires. So while creating the document, one of the primary readers we considered was the external vendor that would be selected to help us move from mods to RDF on our next generation platform. So the robot imagery here is not meant to dehumanize the vendor, but just indicate that we needed portions of the mapping to be machine actionable. And also, while we're certain our future vendor cares about our migration and its success, they can't be as invested as we are in understanding every little detail of the metadata. So finally, we did intend this to be useful to the broader linked data community as well. So as mentioned previously, we found Samvera and Islandora's mapping documents really helpful. So we felt it was important to share this document openly and explain our process as much as possible.
So we did something initially, I think that was controversial by some people in the group, but I think it was something that I think all of us appreciated at the end, which was we did our documentation as code. We didn't use Google Docs, and there was a good reason for that. I think when we were looking at other people's mappings, what we noticed a lot is there was just like small errors that, in code blocks and things like that, that weren't really a big deal, but they were hard for us who were new to all this stuff to really interpret and understand. And so we really wanted to make sure that what we were doing, what we were creating, that we were actually talking about and continue our conversation from even our earliest of our shared readings. And so we decided to do our documentation as code. We did our markup as restructured text and then generated HTML from that using Sphinx, which is like a static site generator the Python community uses for documentation. We use that. We did all of our markup. We committed code with Git in unique branches, and then pushed our branches to GitHub for the purposes of pull requests and code review, where then we continued our conversations before we merged things in and made sure we were all comfortable or had questions about what we were doing. And then we also, no one wants to look at like code blocks and make sure those things are good. So we wrote little, I don't know, unit tests or just tests in general in Python, and use GitHub Actions to run those automated tests before we reviewed our code, just to make sure those things were good. And then ultimately hosted everything and read the docs so that the HTML could be dereferenceable itself, and then also so that we could have PDF generation with its build tools.
So if you look into the mapping document, you'll see that each like category has 4 different sections. Use case, justification, XPath, and decision. And this was partially built on how Samvera and Islandora had approached it. They had a decision portion with both XML and RDF displayed, but we actually added a bit. So we added XPath just so it was really easy to isolate the associated metadata that we wanted and clearly define it. Also for use case and justification, this really helped us determine, do we need this or not? Like, how are we using it? So use case, we would just write down, how are we using this right now in the metadata? For justification, do we need to keep it going forward? Is it something that's required for sharing with DPLA or something else? Is the information even accurate, or is it used consistently enough to provide any value? And also, share a little bit about, why we selected each property and what the pros and cons were. And to give you a little better understanding of that, I've just included an example here, and it's for shelf locator within physical location. We often had included actual shelf locators for archival collections, boxes and folders. Special collections actually updates this information and reprocesses a lot though. So a lot of this is inaccurate information. So, we noted how it was used. We then noted that, hey, this isn't that accurate. The XPath defined where it is. And then we provided the decision with both the XML and the RDF. In making the document, there were 2 tools that were really critical to helping us create it. The first tool seen here is the DLTN Metadata QA, and it was built by Mark Baggett and can be found at the GitHub link below. So it's a command line tool, and it allows you to output all values at like a particular XPath. So here we're just looking at everything under access condition. And it made it easier to kind of define what the use cases were, because you can just look through and see. So, we can see here that there's kind of 5 different XPaths. The majority have an attribute of xlink href and are associated with our standardized rights values from rights statements and Creative Commons. While this was our major use case, we also needed to go through and determine if we needed to keep, the 1 through 4, and, just see what was appropriate for each use case. Additionally, the DLTN Metadata QA helped us in just identifying, little tiny errors that we had throughout. So you can see here the empty URI value, an encoding issue. So we just addressed those through creating some tickets and cleaning it up as we went, which ultimately improved our metadata and will make migrating a little bit easier. Another tool we use frequently is the RDF Inquisitor, and this was also built by Mark. It was created to interrogate your RDF by allowing you to see what your URIs are actually pointing at. And to better represent that, I'm just going to show you results. So here's an example of the EDM data provider URI. You can see that the URI is content negotiable, and it allows you to look at the domain and range for the property. And I know for me, this tool really made me appreciate the complexity of linked data. So while I previously felt like any URI would do, working with this tool revealed to me many cases where URI did not allow RDF to be retrieved, which I didn't really think that much about before. So we're gonna ask another question if you can participate. So, we've talked about the overall structure and process of creating our mapping, but we wanted to hear from people if you have created your own mapping as well. So you can go again to slido.com or just use the QR code. And I'll just sit here for a bit and let the results roll in. And like part of the reason we're asking this is, while we found things from like Samvera and Islandora, we didn't really find any other open examples of mapping documents, and are interested in just sharing those with the community too. So actually quite a few right now have created their own mapping. And I'll give it another like 5 to 10 seconds. Yeah, that's interesting to see. And I'd love to see, have links to some of the mappings here if you do share them openly. Okay, I think we're gonna move on to the next slide.
So I know we're at over the 30-minute mark, so I'm going to try to go lightning fast here, but really I think this is more the most important part. So like some of the things here that I want to say, and issues maybe with our mapping, and things that we just thought about and talked about along the way, and realized about, like, some of our naiveness about even our initial readings, and questions that I think still come up, like in terms of like what we were trying to set out to do, but whether or not we really did, and have we've made things more complicated, or have we even understood certain things? So you can go to the next slide. But the first thing is just like choosing and justifying the right URI. We created this like crazy like set of principles that were like, okay, this is what things should work, and this is how things should look like, and this is how our interpretations of things. But as soon as we started working and started doing stuff, we immediately started to recognize that, hey, this isn't exactly how we thought things would be. So you see above here in section A, that's the really popular Creative Commons CC BY license, right? But the problem is that it doesn't adhere to content negotiation. It's definitely dereferenceable. You can get it at the RDF, but it didn't do what we said it should do, and we had this all the time, where then we were justifying whether or not, oh, do we really care about this? Do we make an exception? Really, should we have had this to beginning? Why did we do this, etc.? Go to the next slide. And hey, this was all over the place. So content negotiation just should not be assumed. Wikidata is interesting, where like the Q names, which I guess are the classes, they're all dereferenceable according to their, content negotiable according to their the URIs that are used in like the Sparkle endpoint, but the properties are not. And again, this is something that we just saw all the time, and that we just couldn't assume that content negotiation was a thing, and it made us question everything. Next slide. And then like, this is like a thing like, we're used to from XML, but like, we read all this stuff about dereferenceability and like the principles of linked data, but then we started coming across like URIs that like, just weren't dereferenceable. We read the Samvera mapping, and they talk about like, oh, for extent, use RDA registry. But then, over time, that URI, it's very similar to like the namespace URIs in XML, where you just can't actually look it up and get anything. You just get page not found, or you need to go like to the RDA registry website and try to figure out what the actual new URI is. Next slide. Also adhering to domain and range. This was something that I think like we thought was really important, but then we recognized that people just don't really, they only do this to a certain extent, or like that seemed to be the practice where and it, I think in some ways like even made us question whether or not we really understood like what we were trying to do to begin with, but like where we'd have this property that other places were using for these things, and maybe they have domain and range properties inside those properties that inform how the subject or object should be used, but they don't really apply to the situation. And it made us question like, hey, have we interpreted this correctly? Should we even care about this? And we found ourselves a lot, I think, justifying what we were doing. And here's an example where, we're using DBO collection to describe a relationship between an object and a physical collection. But, when you start following the path here, it's, hey, this object's not a museum. Next slide. And then grokking domain and range. This is just further on. Like in some ways we're trying to do this, but then you start reading something like this, and I think in some ways people have trouble interpreting even what the intent of this domain property on this property is. Next slide. And then we have this weird thing too, where we're looking at the RDF for all the rules, trying to find about a property, and we find like something like this, which we see as kind of harmless and like, oh, this is easy to implement. But then someone goes along and they find this PDF document that is about this property elsewhere, and it conflicts with what's here. So here we have an RDFS range that just says it needs to be a string. But then when you look at a related PDF doc, there's a lot more things that string should be. Next slide. And then finally, just like, do our decisions align with what we were originally set out to do? What we wanted to do was make something that was, still was captured what we've been trying to do since 2014, but was also easily implementable. But I think in some ways, like we recognize over time and things that we've selected and tried to do, in some ways make that more difficult. I think an example here is like, we have this complex mods above that we've used for years. We've used it for indexing and display. And here we've like, oh, here's how we do this in as RDF. But like we haven't really thought about how this relates to other things in the system, and how like consuming this URI or what we'll have to create to do that, to make this same thing work if necessary, what that actually is. And in some ways, maybe it would just have been easier just to mint a local URI to represent this. And that's it for me.
Yeah, so we're going to transition to just getting a little bit more feedback from the audience, but Jim, definitely let us know whenever we need to finish. But if you can, follow these two links. I'm going to try to put it in chat really quick. Hopefully quick. So there's our first one, and I'll put in the second one as well, but it's, yeah, pretty straightforward. And if I can get to the right one, I'll just put it in myself. So first off, we shared some resources, both readings, other mapping documents, things like that helped us with migrating or in the process of preparing to migrate. And we wondered if others could share, similar resources or other things that just the community should be aware of. And you can just click, this plus button, and it'll allow you to just write in, whatever you want. If you want to share links, that's great. So are people doing okay with that? And yeah, we'll definitely, these will be open for a while. So, if we do run out of time, feel free to add them as well later. And they'll also be there as a resource to everyone, which is kind of what we're intending to, just so people have a place to look. Yeah, and you can upvote or downvote. So please feel free to do that as well.
Meredith, thank you. One suggestion I would make for these links is these could be dropped into the Slack channel for, so there's a conference workspace, and then within the Slack channel, under ontologies and standards, we could drop these links in there, continue the conversation there as well. I do know we probably have about 5 minutes before we need to move to Karen's talk. So I'm curious, can you see the Q&A? There's a couple of comments in there. I wonder if you wanted to take a look at those.
Yeah, so I don't know, Mark, if you want to take the question about Markdown and GitHub for your documentation. I can also speak to that. I think I was one of the people that at first was hesitant But I know for me in the end, I felt like it was a critical decision that really allowed us to be consistent throughout, and not introduce errors. I definitely had some typos that the code caught, so I appreciate it. But Mark, if you want to talk more on that.
Yeah, I'll try. So I think like in some ways, like the philosophy really is driven like from like, and you can read more about this, like the concept of documentation as code in general. But I think in some ways, like we with the things we develop, right? We use like code, like we use version control, and we use like code review processes and stuff like that. But oddly, we don't do that necessarily all the time with documentation. And so what happens a lot, I don't know if this happens everywhere, but it certainly happens here, where you use suggestions in Google Docs or something like that, and then stuff just kind of gets merged. Things are lost. History is lost. We wanted to make sure we had that, and we wanted to, again, I think another thing too about like documentation as code is it lets you do a lot of code-like things. Like you can write tests that make sure that the RDF that you're writing is valid without a human having to check on that stuff. You can read more about like the human can be responsible for interpreting different things. What is grokking? So grokking, I think, is like just like maybe it's a technical term like that. I think oftentimes it's just mean like understanding, or I guess that's how we're using it here. Like, like understanding what is meant by something. That's a good question. What is grokking? I think that's a word that maybe I use it all the time and I use improperly, but I don't actually know what the definition is. And then Joy, you ask, how does ID.gov do in your test? I think it works fine. I don't think we have any problems at all. ID.gov is great and is reliable.
Yeah, I'd agree. Jim, I don't know how we are on time, if it's time to transition or.
Yeah.
Yeah, we'll put the other Padlet just in the ontologies and standards Slack. And it's just asking if you can share, for all those that said that they did have a mapping, we would really, really love to see your mappings. Because yeah, we've looked at all these broader mappings, but on the institutional level, it'd be really great to see. And that's one of the reasons we really wanted to do this session, to get feedback from others. So please do all go ahead and put that in the chat. And thanks everyone for your time.
Okay, that was a wonderful talk and great work, you two. Thanks so much for sharing it. Transitioning to our next speaker here, it's a great honor to be able to introduce Karen. Karen Coyle has been involved in metadata standards development since the early days of MARC usage. Her experience includes membership in ALA, W3C, and Dublin Core communities. Karen currently chairs the Dublin Core Applications Profile Interest Group. And so she will now give her talk on DC specification for simple tabular application profiles. So without further ado, Karen, feel free to share your screen and take it away. See, don't have Karen on the call for some reason. She was here earlier. Let's see. Okay, just to let everyone know, we're reaching out to Karen. If she doesn't end up back on yet, we'll record her talk and post it on YouTube. So we're just standing by to see if we can get Karen back on here. So please stand by. Let's see. Karen. Can you hear me, Karen? Feel free to go ahead and share your screen and you can start your presentation.
I would, but Zoom just crashed on me. So give me a second to get ready.
All
I'm
right.
having to run this on a different machine.
That's all right. That's all right.
Yeah. It just completely went away. So let me get this ready here. And Zoom, share my screen, and share my screen and start up. Okay.
Okay, looks great.
Yeah, let me just, this is kind of quick because like I say, I just lost my main computer, but there we go.
Okay.
Hopefully I can do it from here.
Yep.
So I'm wanting to give you a bit of an update on what we're doing in the DC TAP. And just a moment, because I'm going to update my slides first. There we go. Okay, now I'm ready. Nothing like having your machine die in the middle of something. So we've been working for quite a while, and you may have attended one of our webinars for creating an application profile that is very simple, very Dublin core, and that is tabular in nature. And I want to give a shout out first to everyone who has participated in this. Thank you very much. And we've also gotten many interesting comments from folks not listed here and from other communities. Now, just to let you know that that Dublin Core has been working on application profiles actually for quite a while, and has its own definition of application profile, but which I believe it does not vary really from what most people are talking about when they say application profile. So an application profile in the Dublin Core sense defines a particular metadata practice. And it may also give constraints on what properties you use, what values you use, that type of thing. One thing that is specific in Dublin Core, and I think is a very good rule, is that a profile defines a particular set of properties, but it also is by definition a reuse of vocabulary terms that have been previously defined. And that means that if you have things that you need to do that haven't been previously defined, you're going to have to define a vocabulary term before you actually use the term in your application profile. Now, you may be wondering why we went with a tabular view of application profiles. And the reason that we did is that what we've found is that most people, when they create their application profiles, they create them as documents. And in those documents, at least somewhere, they define their terms and the constraints on their terms in a table format. And I honestly think that, we humans are just sort of list makers, that we think in terms of lists. And so we looked at a number of different application profiles, all of which most of which were done as documents. And we used what we saw there to develop a more standard tabular format so that people could be using a similar format, because as you see here, there's quite a bit of differentiation in how people express themselves. The functions that we have developed for the application profiles is first, a profile lists the properties that it uses. It defines constraints on those properties. It develops, it has readability. We want it to be readable by a human being. You can then group those properties into shapes, or what many people think of as entities. And then as we got developing, we discovered that it was hard to develop in a totally generic application profile model. And so we developed it with RDF metadata in mind. So there are some kind of you'll see some RDF thinking in it. It uses only 12 elements, and yet these 12 elements cover quite a bit of functionality, which I'll go through here. The only thing that is required is that you have to say what your property ID is. You have to say what the element is in your that you're going to be using in your metadata. So other than that, everything else is optional, and also the order of the columns is optional. You can you can have quite a bit of flexibility. Usually people want to add a data type. They want to add a data type to say what type of data that their property takes. So of course we have that in there. Everything can get a label, or the properties and shapes each can get a label, and then you can add notes, whatever notes you want. A key element is cardinality, that that you can say that it's mandatory and repeatable. And I know that many people like to use the 0.n type cardinality. We weren't sure that that was universally known. And so we instead used mandatory and repeatable, which we thought would be more in the line of speaking of someone who doesn't code. We wanted this to be usable and understandable by folks who don't actually code, so that you could have, for example, your catalogers, your metadata people could express themselves in this table. Now, something that is very RDF-y is this value node type. For many RDF functions, and in particular for validations such as in shackle and checks, you need to say what the node type is. And so we added a column for value node type, IRI, literal, or B node, and the value data types as defined in the RDF schema documentation, excuse me, are all literal data types. You often want to say more than just this is a string, or this is a date, or this is an IRI. And so we have developed a fairly simple way to do that, but it can be expanded. So in this case, what you're saying is that my IRI is going to be a stem, which I think in BibFrame, it has something like values from. And then the constraint is the beginning part, the main part that this IRI will be taken from. And I know that this is shorter than the actual IDLOC.gov one, but I wanted to fit this into the table without it getting to be too big. So we've done a sort of a starter list on the value constraints. And the starter list that we've come up with, and this can be expanded, but we thought these were some of the key ones, and they demonstrate what you can do with these value constraints, is a pick list that is within your profile. You're actually going to say what the possible values are. Your IRI stems, of course. Pattern, which would be a regular expression usually, and then what language tags are acceptable for people who are doing things in different languages. What I've shown you so far is something that we call statement constraints, and statement constraints are the property ID and all of the things that define and constrain that property. So each row here is what we call a statement constraint. And I know that that's not a commonly known term, but it's going to come up again, so I wanted to define it for you. The other thing is that we're quite aware that in many cases, if not most cases, people's metadata has more than one thing that's being described. Again, usually people call these entities. We are referring to these in the profile as being shapes, which also resonates with the RDF terminology. So shapes connect to each other, and each has its own properties, its own things that describe the shape. To do this, we have a shape ID, which again can get a label. And each shape is a group of statements that share that shape ID and conceptually that subject in the metadata. So here you can see that you've got the book shape and you've got the person shape. You link shapes together with a column called value shape, and value shape, for it to link, the value shape and the shape ID have to be exactly the same string. And what this is saying is that my creator is going to be a person shape, and then the person shape gives all the information about that. And yes, this could either be an IRI or a blank node conceptually, but you're basically moving from node to node in your RDF. Now, although we've conceived of the tabular application profiles as being machine actionable, what we are also discovering is that people are finding that using this model helps them think about their metadata. And so moving from, for example, a document that has a diagram and then it has, a list of properties in it, to the TAP has given people a way to get a better vision in their own sense of their metadata. And that is exactly what we have often thought of as the application profile, because it's not only an end product of your deciding how to do your metadata, but it's also a way to think about and communicate amongst yourselves as what your metadata really is when you draw it out like this. If you wish to create your own tables, we have on there our GitHub, which is the DCMI DCTAP GitHub repo. You can grab a template. The template, if you look at the template in GitHub, GitHub does a really nice display. So it looks like a table, but underneath that, it's actually, this rather ugly CSV. And I promise that I will create in the same repo right underneath here, ones that can go directly into Excel and OpenOffice. I meant to do that before today, but failed. Okay, so now I want to get into some of the really more advanced stuff that we've done since we last presented anything about this. So we're seeing this tabular application profile not as an end product, but as a beginning of an entire workflow. So the table, and this table looking at it as a table, say in a spreadsheet, may be what you use as documentation for yourselves, that needs to be output as a comma-separated value file. Once it's output as that, we can see this moving into being used for input forms, for validation. There's some thoughts that we may even be able to derive documentation from this. Oftentimes you find that the documentation for humans and the machine actionable values end up having some conflicts. It would be nice if instead it was all generated from the same place. So as a proof of concept, the group, and this has been led by Tom Baker and Nishad Thalath, have developed a program that takes the output, the CSV output, and does some processing of it. What it does is, so it takes the CSV as input. It can be customized with a configuration file. I'm going to show you that. It does some basic checks on the table, and you'll be able to see that. I'll show you where the documentation is. And the way it is currently is it outputs text, JSON, or YAML. Those are your options. Let me just say that this is a work in progress. There may be some other things that are shown here that appear in this program, other functions. We have things in mind, but the way it is, it's stable for what it does. There's a lot of documentation, and there's a lot of documentation. I was sort of smiling when Mark was talking about this, because again, we're using read the docs, and therefore the documentation and the program are very much in sync. The main repo is at GitHub is under DCMI, and it's DCTAP Python. There, the README will lead you to whatever the other documentation, and it also gives you some information about installing. The read the docs is really quite extensive, so you should be able to get anything you need in terms of understanding it from that. This gives you an idea of what the YAML output looks like. Obviously, couldn't fit it all on the screen. But you can see that it has shapes, it has statement constraints. And then this is the JSON output, which again is very hard to show on a screen like this, but that does the same thing. The install, you can obviously, you can clone, you can fork as you wish. But there is a very simple pip install that you can use, and then running it is again quite simple. In the command line, it's basically command line only at this point. You can use the help, you can use a -- help to get more information about what the options are. They aren't very extensive right now, which is nice because it makes it easy to run. I posted this to Code for Live and then forgot that, of course, it doesn't do you any good to try to run a program if you don't have any input. And I forgot to point to, we do have under DC TAP, we have some examples. If you drill down into these, if anytime there's a CSV, you can use that as an example. You can, try making changes, that type of thing, just so you've got something to get yourself started. At this point, the program only stops if you have no property ID, because that's the only thing that's required. It will, however, give you some warnings about your data. One of the ones that I really wanted was any column header that isn't known, because the chances that people will typo the column headers are pretty high. So it'll tell you if it runs into a column header it doesn't recognize. And then I will show you about how you can configure if you're wishing to add column headers. It also does some checking of the contents, but not a great deal. So again, it's pretty flexible. So one of the things that's really important about this is that it has a configuration file. So when you install the program, if you just type in DCTAP space init, it's going to create a YAML file that is the configuration file for the program. This, when you first do it, it gives you the defaults. The next time you run the program, it's going to read from this file. So this is where you can make changes. And I'm going to give you some examples, but you'll find much more in the documentation. One of the key things is, of course, that you need to define your IRI prefixes. And these are ones that are built in, others may be added in this built-in group, but essentially you can just add in your own. The other is that one of the requests that we often get, so we have these 12 columns, and we don't really want to expand that beyond there if we can help it, because what we want is a very core set of elements for an application profile. But everyone's going to have something else they need to add. And so there is a way in this configuration file to add different elements, new elements. So one of the ones that we were asked for by Jason Littman was that he needed to say which fields, which properties took an ordered value, or they had to remain in order. This is for often for things like creators. So if you wish to add that column in your application, you can do so using this extra statement constraint elements. And you can obviously add more than one. Another one that has come up is for those people using Shackle, that within the application profile, they would like to say there what the severity is. So as I said, that the TAP is it's not an end, it's a beginning, and we see it as being a step one, a friendly step one for people working with their metadata, wanting to create application profiles, and then this data will be reused elsewhere. Some of the next things that we're looking at are after this first program that basically does a very simple reformatting of the output, is to move from there to see how well this can be translated directly into either SHEX or Shackle for validation. Now, I should also say that this is a program that's been developed within the group. It is not, again, not an end, it's a beginning. It's in Python. If someone would like to write, a similar program that is in, Ruby or whatever, please feel free to do so, and please let us know, because we would love to be able to point people to it. As much as possible, we want everything to be reusable and flexible. We're continuing to work. We're not at the end either. There's a number of things, and this is just a few that come up frequently, and that we are continuing to think about. Of course, how can we internationalize this as much as possible? Can we allow, there are limitations when you're doing things in a table format. So the question is, can we allow more complex if then else and or not type description in the table? And there also are many people whose we've run into already, whose application profiles would be very long and complex, and they would like to do them in multiple tables, and then in that way, when we have to think about where and how they would be combined. So we would love to hear from anyone trying this out. There's lots of ways to participate. It's all very open. You can open issues on GitHub. We have a mailing list. So if you go to the DC TAP repo, you'll see there in the README, it'll tell you where the mailing list is and how to subscribe. We would love if you have data that, or you have, for example, either data that needs to be profiled or profiles, and you would like to see if they work with this, please get in touch. We're already working with a number of different groups, and this helps us, is going to help us get further in terms of developing this, because we need to try it out in some real live situations. So that's what I have, and I can stop share perhaps, but I would also like to see where we are in the Q&A, which I'm not.
Thanks, Karen.
Yeah.
Yeah, we have some questions coming in.
Okay, let me stop sharing, and then I can look at the Q&A, and I will try starting my video. There we go. I'm in a completely different place from where I started.
No problem. You did great.
Yeah, nothing like having your computer die right in the middle of you giving a presentation.
You did wonderful with it. Thank you.
Do we have any other questions?
I can read this one if you want. It's, let's see. So they like the idea of starting with a small set of core elements and adding as needed. They imagine it helps scope the work as opposed to, say, 3,000 plus elements in RDA, as well as make it more user-friendly. So the question is, what other benefits have you noticed from keeping the element set smaller?
Well, it is, okay, first, our set is not like the RDA 3000. Our set, and this is, we run into this all the time. There's a meta problem here that what TAP does is it describes the elements that you need to include in an application profile. It doesn't describe the profile itself. So rather than the 3,000 elements of RDA. And actually, one of the things that one of the examples and is I took a chunk of RDA and created a small profile from it. So you can see that these complicated and long and involved and detailed what I call metadata descriptions can be fit into those 12 elements. Now, again, many people are going to want to expand those 12 elements by one or two things, but it really does cover the core.
Great. I see we have a hand raised. Paloma, should we unmute for the raised hand?
Or should we check in the chat?
We can check the chat.
And see.
Oh, there it is. In the chat.
Oh, good. John noted that one of the examples is he did a mock-up. John Huck is one of our active participants, and he did a mock-up from the Samvera mods to a profile. So it would be interesting for folks to look at that who are, given that we've just heard a lot about Samvera mods.
Yeah, may I read you a Q&A question from the Q&A here? The DLF has a metadata assessment working group that has collected a bunch of resources about metadata application profiles. They're curious if you're aware of their work, and have you tried coordinating with them? This project seems to fit nicely into what that group's doing.
Mm-hmm. Yeah, we haven't yet connected up with the DLF or the Europeana folks, and I think we need to do that. We are working with some other folks, such as the data site people, and I'm working on a DCAT, which is the data catalog folks. So that's a great suggestion. I don't actually know anybody who who's at the DLF right now. So I'm going to get on that. I like that idea.
Okay, thanks. And it seems like several of them, they're here, and so that they can email
Good.
you or
Hi.
Yeah, that's great.
Let's get together.
Sure.
Yeah, no, I think that would be very interesting. I mean, each one of these that we work on takes a bit of time, and of course time is limited. But yes, I think we're at the point where it'll be good for us to branch out.
Yeah. So here's another one in the Q&A. They say they really appreciated what you said about how using TAP helps with metadata modeling and visualizing your metadata. They see the potential to use this with their students in an LIS metadata class. Have there been any discussions about perhaps using this as a teaching tool?
Well, you're the first we've heard from who'd like to use it in teaching, and I think that's a great idea. Feel free to get in touch. We'll, we can chat about it, give you any information you might need. I really do think that the structure that we've created, the model that we've created, helps people who haven't thought about it before think about what are the things I need to define for an application profile that truly works and defines my data. And so I can really see how that would work in teaching, because you're dealing with people who probably haven't encountered this before. They haven't done the painful trial and error of developing their metadata description. And I would love to chat with you about that. And I would love to hear afterward what your results are.
Thanks, Karen. Yeah, they said that another comment, they're extremely excited about the DC TAP their workplace about to embark on a metadata quality project, and DC Tap seems like exactly what they need. So,
Well, great. Let me see who that, let me get back to chat and see. Ah. Yeah, yes, so anyone using it, even experimentally and you know, that, please, please send us an email to the email list or to me personally, because we really want to see how this is being used, and it helps us a lot in terms of further development to see what it is. And if you join the mailing list, it's you know, like maybe 2 emails a week. So don't worry about getting overwhelmed. And also anyone who gets, please send us any comments or questions or suggestions in GitHub. And if you email them to us, we may end up putting them in GitHub anyway. The GitHub is pretty extensive.
great.
It sounds like a lot of people are going to be joining the mailing list.
That'd be great. Yeah, that'd be great. Yeah. And any comments on our documentation? I forgot to mention that we primarily have a primer. That's our main documentation. So you will find that at the DC Tap GitHub repo. And that document is also available on the Dublin Core site. And if I weren't on a tiny laptop, I would I would get that. Maybe Tom Baker, who I think is here, can get that and post the link to that on the Dublin Core site. So this is, by the way, also the document that defines what we do have in the DC Tap Python program. So it's based on that basic primer. And oops, sorry, Tom. The DC Tap primer on the Dublin Core website. When we put it there, see if if someone can come up with that. So I see a good link to okay, to the DLF. Let's see what that gets me. Oh, great. Okay. Yes, thank you, Tom. That is it. So that's where the primer is on the.
Karen, we seem to have lost your audio.
Huh. Oh, there it is. Sorry. That has to do with me putting my hands in the wrong place on the laptop.
We have a couple raised hands. Should we see if anybody wants to contribute?
Sure.
Going to allow to talk.
It's fine with me.
Rhonda, do you want to share something?
You have to unmute. Oh.
Maybe
Someone says, will you
multitasking.
put these links in this Slack channel? Yes, I will put a bunch of links in the Slack channel. And also I haven't uploaded my slides yet. So I will upload my slides here. And then I'll also upload my slides on the DC Tap GitHub, where we're also keeping, we have a subdirectory for various presentations and documents, that kind of thing. All these things I need to remember. Does the chat come through in the recording?
It will not, because we are doing this through streaming in YouTube and then publishing it on YouTube. But we can save the chat and we can share it on Slack as well.
That would be great if you can save the chat, because there's always things that go scrolling by, and
yeah, absolutely.
especially when people put in links, it's really useful to have those.
Absolutely, we will do that.
Anything else?
Not seeing any in our
Okay,
Q&A.
well, either it was perfectly clear or it killed the audience, and I don't know which it was. You never know when you don't get questions. So, oh, good, someone's been looking at the documentation. So credit that to Tom Baker, who the documentation is really great, and it helps a lot to have good documentation.
Yeah, I think that's a theme from this talk, this whole session. And thanks so much for introducing this. And I hope you'll keep sharing this, and excited to see the engagement going forward among the various communities here. So thanks so much, all of our presenters today.
You.
And yes, thanks so much to the audience for the questions, and have a great rest of your Friday. Thanks so much. Bye-bye.